Hey everyone, welcome back to the series where we are building a whiteboard Android app from scratch. In the last video, we covered the essentials of working with compose canvas and paths. Today, we will dive into state management, handling events, and using a view model to create and store paths for different shapes efficiently. So, let's get started. Here, first, let's go to our whiteboard screen and scroll down, and in our drawing canvas function we are keeping the list of paths and current path using this remember. Let's run our app and see how this is not a good idea to keep the state like this. Now let's draw some path, and let me rotate the screen of this, and now we can see on this device configuration change it has lost those state values. So what we can do here, one solution is that we can simply use remember savable instead of this remember, like we are using to keeping this is card visible state. But there is a better way to manage these state. We have a view model for this. First thing, we need to add some dependencies relating to the view model and compose lifecycle. Then we will discuss about view model. First, let's minimize this. Here type the compose ViewModel dependency and this second link. Scroll down. Here we have these dependencies, but we need only two dependencies from here. This one for compose ViewModel and this one for the compose lifecycle. So first let's copy this part, and in our Android project here we have a file with the name libs.version, and scroll up. And here we already have one dependency for this lifecycle runtime. First, let's make a copy of this, and the name of this dependency will be this lifecycle viewModel compose, and also update the name of this here. And the group name will be the same Android lifecycle, and the version will also be the same. Let's copy the next one. This one lifecycle runtime compose, and make a copy of this again, use that name, and all three will have the same group name and same version name. Next we need to go to this build.gradle module level and scroll down, and here we have this lifecycle runtime, so let's duplicate it two times. First will be this lifecycle runtime compose, and next let's see the name lifecycle viewModel compose. Now we can sync our Gradle. It has been synced, so let's close these two files. And here in our whiteboard package, let's create one more class with the name whiteboard viewModel. And we need to extend this with this viewModel from this Android lifecycle. So what's this viewModel? This is a class that is designed to manage UI related data in a lifecycle conscious way. It is specifically meant to hold and manage the UI state that needs to survive configuration changes like screen rotation. And I will also list out some of the benefits, but first let's do some coding. Go to this whiteboard screen. Here we are keeping these state like this. But what states are If I say in simple terms, states are any value that can change during the app usage, that is state. Here these things are those values which can change during the app usage. So what we need to do? Here in our whiteboard package, let's create one data class with the name whiteboard state. And this data class we will use to keep all these state related to this screen. Here as the Android Studio is suggesting, we need to keep these states. So let's press tab and we need to import this compose UI graphic and go back to our whiteboard screen. And here let's create two state for these two values also. For now we will keep these state only, but as we will add things in our screen, then we will also add those related state into this data class. And here I need to change one thing. Instead of keeping this simple path, we also need to keep the selected tool related to this path. So what we need to do here in our domain model package, let's create one data class with the name drawn path. And here first keep the path and also the drawing tool related to this path. And this drawn path we will keep in our state. So this will be our data class. And this data class we will manage in our view model. So let's go there. First we will keep a private value for state and we need to use this mutable state flow. And initially we will keep our whiteboard state data class with those default values we provided in that data class. And next let's also create a state value for the public use. I have created these two because this private one we will use inside this view model to update the state. But outside this view model we will only use this public state for read only purpose. So in this way we will make sure that this state value won't change outside this view model. And these state we will pass to our screen and we are using our screen in our main activity. So here first let's initialize our view model and we will do so with the help of this view model and the type will be our whiteboard view model. And open our imports and we can see this view model is coming from that dependency we added in our Gradle file, this lifecycle view model compose. And we need to pass those state in our whiteboard screen. So first let's create a parameter here like this and go back to our main activity. If I pass the view model state like this, then this will give us the error because we are keeping this state as the state flow. But we need this state inside our composable function as the state, not that state flow. So what we need to do here, we will collect those state flow values as the state. And if I type this collect, and here we have this function collect as state with lifecycle and also import. And if I open the imports again, and we can see this collect as state with lifecycle is also coming from that dependency we added just now, this lifecycle compose. And now we can see our state is of type whiteboard state. and we can provide this to our screen and go back to our screen, and we will use this state wherever we are using these. First here, state dot is drawing tools card visible, and copy this and use it here. And this selected tool, again we can simply use this state dot selected tool and copy this and use it here also. And these on clicks, for now just delete these. And in the same way, let's delete these states also. And this code, for now just comment out and delete this one. Here first we need to pass the state to this composable function also, and we are using this here. And now we can use these paths from our state, and we will get the drawn path, and we will use this drawn path to get the path. And same let's do for this. And for this preview function, we can just simply use default states. And we can also delete these paths because these were just created for learning about the path. Next thing, we need to understand what the events are. Events are simply user's action, what user can do on the screen. So here user can drag the screen, so this is one event. And also user can also click on this fab, then our toolbar will open, and user can also click on any of the tool and also click on that close icon. So these all are events. So again we will create a separate class where we will keep all these events related to this screen. So in our whiteboard package, let's create one sealed class with the name whiteboard event. So I will create all these events which I explained you right now. So these will be our events related to this screen. Here for some I am using the data class, but for some I am using the data object. The reason is if we want to pass some value also with the event, then we use the data class, otherwise we use the data object. Like when user will click on the drawing tool, then we also need to pass the drawing tool user has clicked. And in the same way, these start drawing and continuing drawing, we will also pass offset with them. And these events we will manage in our view model. So let's go there and create one function with the name onEvent. Here let's press Alt Enter, add remaining branches. And let's also attach these events in our screen. So let's go to our whiteboard screen and scroll up. So here we will use this on event, and we are using this whiteboard screen in the main activity. So let's go there, and here we need to pass this on event function, and in our screen let's attach these events to their respective on clicks. First we have this fab, so here we will simply use this on event and we will pass this on fab click event and make a copy of this, and let's also use here, but this time we will pass this on drawing tool selected, and we also need to pass the tool, so we will get this from it, because from this composable function we are already passing this drawing tool. And let's rename it to, and scroll down, and here in our canvas function also let's pass this on event function. And for the preview we can simply pass the blank parenthesis, and here attach those events. Now we will update our states. Here we have this fab, and here we are passing this on fab click event. So let's go to our view model, and this on fab click we have here. So here what we will do, we will simply take our state and we will use this update function, and we will make a copy of our whole state data class, and we will update this is drawing tool cards visible to true, and this will make our drawing tool card visible, and this state we are using here to get visible of this drawing tool card, and also it will hide this fab because we are using the negative condition, and initially we are keeping this state as false. It means our fab will be visible initially. So this is how we update the states in view model. Now next thing, here we have this on tool click event, and we are using this event here. So here let's also update our state, and we will update this selected tool to whatever tool we are getting from that screen, and initially we are keeping this drawing tool as the pen. And next let's scroll down, here we have this on drag start, so we have this start drawings, let's move it to the first line, and here we will simply update our starting offsets, and we will update these starting offsets whatever offset we are getting from the screen. And next we have this continue drawing event. So for this we will create a function with the name update continuing offsets, and we will pass the offset to this function, and we don't have this function, so let's press alt enter and create function with this name, and we will keep the name of this. So this function we will use to create the path of different shapes and that freehand writing. First let's create this updated path, and here we will use this when block with this state dot value dot selected tool, and we will update the path according to the selected tool, and press alt enter at remaining branches, and we have these different tools. Here some of the tools have similar way of creating paths. So what we will do, we will combine those tools at one place, like this pen, highlighter. So let's cut from here and use it here. And in the same way, this laser pen and also this eraser. So these four things will have the similar way of creating the path. And similarly for this plain line and this dotted line, again we will create a single path for this, and in our screen we will draw these lines differently. And let's do the same for these arrows. And next, for creating paths for these tools, here let's create one private function with the name create freehand path. And for this function we will provide the start offset and also the end offset, and this function will return us the path of this compose UI graphic. So the creation of this freehand path will be exactly same as we created in the last video. So let's go back to our whiteboard screen and cut this code from here and paste here and uncomment it. First thing, let's call this function from here, and this needs the start and end offset. And start offset we can take from our state, and end offset we are getting from this function. And let's add the names to call arguments. And the Android Studio, here it is saying that some of the tools doesn't have the path. So what we can do, we can make this value as the nullable for now and use the null value for all these. Now this won't give error anymore. And this function, let's update it. First thing, let's get this current path from this state dot value dot current path. And from this current path, let's take out the path. And if the current path is null, it means we are drawing the first time. So we need to update this path with this move to function. And here we will provide the starting offset. And here we can simply use this return keyword with this return path. And here what we are doing, first we are adding the existing path, then we are creating the next line with this line to function. So this function will be called continuously until the user take off the finger from the screen. So we will get this updated path from this function, and this updated path, first we will put a null check, and if this is not null, and we need to update the state of current path, and this needs the drawn path, and we will provide this path and also the drawing tool. And this state we are using in our screen here. So now let's run our app. Here is our app. Now let's draw something, and we are able to draw it. And if I rotate the screen, our state value has not lost. But here we can see this is connecting the current path because we need to update some more code also. In our view model, Here we are updating the current path, but what we need to do in our finished drawing, we will add this list of path with the current path, and on finished drawing we will also make our current path null. So whenever user will start again, then the new path will create. Hey everyone, if you are finding this tutorial helpful, you will love my premium Udemy course where we will build Measuremate, a fitness app using Jetpack Compose. We go in depth on the Firebase authentication, Firestore and more. Check out the course in the description and take your skills to the next level. See you there. So now we have created the view model and also we are handling the states and event within this view model. So the benefits of this view models are: first, this view model is aware of the life cycle of the activity it is associated with. It survives configuration changes like screen rotations, meaning the data it holds isn't lost when the screen is rotated. And next benefit is using ViewModel to manage UI state allows us to keep our composable stateless and focus on rendering the UI. It promotes better separation of concerns, leading to cleaner and more maintainable code. And next, this view model allows for easy management of UI state and logic, which is crucial for complex UIs that requires data to be fetched, stored, or manipulated over time. And we also need to keep in mind that the view model always keep this state only in the memory. So if I close my app and start this again, we have lost that drawn path. And if we want our past data to be persistent, meaning if we close this app and start it again, then we should able to see the drawings we created last time before closing the app. So for this thing we need to keep the data either in the local storage of phone or somewhere at the server. So for our app we will use the internal storage to keep the data using the room library which uses the SQLite under the hood, but that we will do in the future videos. But for now let's create some paths for these shapes. So first thing, let's minimize it and scroll down. Now let's create a function to create the path of this line. Let's make a copy of this function and rename it create line path. And this path will be quite simple. Here we will simply specify the starting point with the help of this move to function, and we will provide the x and y offsets like this. And with the help of this line 2, we are specifying the endpoint of that line. So this function will be called continuously, and here we will provide the end offset continuously. So that line will be dynamically changed according to this end offset. And we can simply call this function here. And in our screen, here we are using these paths. Simple line can be drawn with this path function, but we need to customize the path of that dotted line. So here we will save this path effect and we will use this if condition. If the drawn path drawing tool has this line dotted, then we need to create a path effect. So for this we have this dash path effect, Android Compose UI graphics, and we need to provide how long that dash will be. So we are saying that we need the dash of 10f and then we need the space of 10f, and this pattern will be continuously until the end of the line. and in the else case we can simply use null. And here we are using this stroke. Let's also pass our path effect. And in the same way, let's do this calculation for the current path also. Now let's run our app and see how this is looking. In freehand writing we can do this, and if we select the line, and here we can see we can draw the lines, and if we select this dashed line then we can also do so. So this is how that line path will be created. And in the similar way, let's now create the path of this rectangle. Here go to our view model and scroll down. Let's make a copy of this function and just create rectangle path. For the rectangle, here we have a function in this path class with the name add rectangle, and we need to provide the rectangle. So we have these four overloads, and we will provide this offset and size. So let's use this offset and size. So this rectangle will start from the starting offset, and this needs the size, and size we need to specify the width and then height. So here the main thing will be to calculate the height and width of this rectangle. So the calculation will be quite simple. You can see this rectangle on a graph. So here we will simply make the difference of these x and y offsets. But here one more thing we also need to consider. This calculated value can also be in negative. So to prevent this, we can use this function absolute from this Kotlin math. And let's provide this value. And what this absolute function will give, suppose if the value is minus 15, then it will provide the 15 absolute value. It will ignore the minus value. And same let's do for this. And let's use these two values here. So this is how our rectangle path will be created. Let's call this here. And first let's also create paths for these two also. Then we will see the preview in our app. Let's take a copy of this, and this time we will create the circle path. And here again we have a function name with this add oval. And again this oval be of type rectangle. So this time we will use this rectangle, but we will provide different values, the center and radius. So let's use the center and radius. So the center will be the starting offset. Now we need to calculate this radius. So the formula of calculating the radius you can see here. If you don't know the formula of this, you can always search the Google and see how this formula has been derived. So let's calculate this. We need to use this function square root from this Kotlin math. First we are calculating the square of x-axis difference. Then we are calculating the square of this y-axis difference. And then we will make this square root. Radius we can use here. And let's call this function here. Now this triangle. For this triangle, we don't have any predefined path function, but we can calculate ourselves. We need to specify these 3 points, and with the help of these 3 points, we can calculate our path. So the first point will be our starting offset, and next we need to calculate this bottom left vertex, and this bottom right vertex. And here we will make a line first to this bottom left vertex and next line to this bottom right vertex, and then we will close this path. Now we need to calculate these two vertex value. So first thing, let's create the height. Height will simply the difference of these y axis, and we will take the absolute value of this, and here let's define the y value of these vertex, y value of starting offset, and then we will add our height, and same we will do for this bottom right vertex, because both these points will be at the same y axis. And now next we need to calculate this x value. For this x value we will calculate the half base width, and this calculation will be simply the difference of this x value, and we will divide this from 2, and here start x offset, and we will minus the half base width, and for bottom right we can add the half base width. So this is how our triangle path will be created. Let's make a copy of this and use it here. Now let's go to our screen and we need to make some changes. Here this style we need to define with the if condition. Let's use this drawn style and use this when block. And here we will use this drawing tool dot circle filled and drawing tool dot rectangle filled and this drawing tool dot triangle filled. Then we need to use this fill as the style, and in the else case we can simply use this stroke, and here let's use our drawing style. So this is how we specify that if the drawing tool has these 3 shapes selected, then we need to use the fill style, otherwise this stroke. So this thing let's copy from here and use here also. And now let's run our app. And the line we are able to draw, this is how these shapes will be drawn. So we are able to draw all these things. So here we have not provided the path of this arrow because the calculation of this arrow path is quite long. So I need to look into this calculation and also how we need to save this arrow path into the local database. So for now I will not provide this arrow path, but I will do so in the future videos. And for this laser tool and this highlighter we already have provided the path, but the color effect we will provide also in the later videos when we will implement those color cards. So that is all for this video, and before we wrap up I want to share some exciting news. Moving forward, I am planning to transition this project to the Kotlin multi-platform. So we can build our whiteboard app not just for Android but also for desktop. We won't be targeting iOS because like many of you, I am using Windows machine and iOS development requires a Mac. And as for the web version, we will hold off for now since Compose multi-platform is still in alpha for web. What are your thoughts? Please let me know in the comments. I would love to hear your feedback and ideas as we continue developing this app together. Stay tuned for more updates and make sure to like, comment, and subscribe if you are excited to see more. And remember, if this video hits 50 likes or 50 comments, I will release the next part of this series. Thanks for watching, and I will see you in the next one.